Covariance. From the name itself, you would have guessed that this has something to do with variance that we learned in the previous lectures. Variance can be either written by like this or sigma square. So in variance we had seen it is the measure of dispersion from the expected value of that variable. Coming to covariance, you can automatically guess that it's not about a single random variable, it's about two random variables. That is, variance was done for a single random variable. Covariance is between two random variables, let's say x and y. So covariance is a statistical measure that quantifies the relationship between two random variables. Let's say we have random variables x and y. What does the covariance of x and y this denote? This tells you how are these two variables varying together. That is, if you have a positive covariance, that means both of these values x and y change in the same direction. That is, if x increases, then y also increases. If x decreases, y also decreases. That is positive covariance. If it is negative covariance, that means if x increases, then y will decrease. This is negative covariance. So positive means both are in the same direction. Negative means they are in different direction. Now, how do you find out covariance? Let's first write what is covariance. See, let's write the formula and from this understand. In terms of variance, what did we do? We took expectation of x minus e of x square, right? This is what we did in variance. So this was for a single variable, that is single random variable x. Now for two random variables, how do you find covariance? You would find expectation of, here you have a square term. If you split it and use it for each of the random variables, first term will become x minus expectation of x. And what will the second term become? Sorry, not minus, it is multiplication. Y minus expectation of y. This is what you call as covariance. So it is expectation of x minus expectation of x into y minus expectation of y. And this expectation of x, it can also be written as mu x. And this expectation of y can be written as mu y. So both are one and the same. Okay. So covariance between random variables x and y, this is calculated as expected value of the product of their deviation from the expected value or the mean. That is, how much is x deviating from its mean, how much is y deviating from its mean. Then you would take a product of those and then you would find the expectation of that. This is how you find the covariance. So let us take an example and understand. Let us take the same movie rating example that we took. In that x was supposed to take the values 1, 2, 3, 4 and 5 depending on what is the rating given for this particular movie by the audience. Okay, so let's say there is another variable y and y says how many days did this movie run in the theater. Did it run for 20 days, 40 days, 60 days, 80 days, 100 days, 120 days, 140 days and so on, let's say. So can you guess what is the relationship between x and y? In general, we can intuitively understand that if y increases, that is the number of days this particular movie plays in the theater, if that is increasing, that means more people are going and watching the movie, which means the movie should be having positive reviews, right? So if y increases, x is also supposed to increase. So we think that we should be getting a positive covariance between x and y if x is the rating of the movie and y is the number of days the movie is playing in theaters. So this is how the reason why you find covariances in this particular case. Before you calculate covariance, intuitively you understood that okay, if x increases, y should also increase. But this does not always happen. Many times when we are solving machine learning problems, we may need to identify whether two different variables are varying together. In case they are varying together, are they in the same direction or are they in the opposite direction? So to find those, you will first need to see covariance and have a mathematical understanding of how these are varying. And one thing I want to tell you is that See, you already know larger values of covariance, whether it be positive or negative. If it is larger value, that means relationship is strong. But at the same case, if covariance value, if let's say if this turns out to be 0, what does that mean? There is no linear relationship between them. And here I have to make a point, that is, if covariance is 0, if covariance of x, y is equal to 0, this tells you that there is no linear relationship between x and y, but this does not mean that there is no relationship between x and y at all. Covariance can only measure linear relationships. That is, if there is non-linear relationship between x and y, still your covariance can be 0. So covariance 0 does not mean x and y are not related at all. Covariance 0 means x and y do not have a linear relationship, and covariance high means x and y have a very strong linear relationship. Okay. Let us now express this particular covariance term. Let us say you have random variable x, which is expressed as, let's say it can take values of x1, x2, let's say up to xn. Similarly, random variable y can take values of y1, y2, let's say up to ym. Okay, let something like this. In that case, how would you find covariance of x and y? You want to find expectation of x minus expectation of x, right? You would write it as x minus expectation of x into y minus expectation of y. So why am I writing this yt? Because this is in vertical. So this same one-dimensional matrix, if you write like this, y1, y2 up to ym, then this is the transpose of this matrix. So in order to show that this is in horizontal, that's why I'm writing a transpose here, expectation of y transpose. So this is how you do in matrix form. Okay, so this is the covariance of x and y. If you solve this, you will reach here. That is, you will reach expectation of x y transpose minus expectation of x into expectation of y transpose. If you solve this, this is where you will reach. So basically you want to understand what is the difference between covariance and variance, and what is the significance of covariance. That is, where would you want to use covariance? If you want to understand how your two different random variables are varying together, that's where you use covariance.